are actually seeing this backpropagation. We'll try to finish this first, and then we can move into our practicals on clustering algorithms in Unit 5. We need to extend this and see how the backpropagation will happen and how these weights will update. So what will be the plan from my side is, I'll be explaining what we have seen in the last class, and then we will be proceeding into the calculation terms of these updated weights, right? How to calculate the updated weights in the back propagation, that is backward pass, right? So simply what is back propagation is nothing but it is a supervised learning algorithm for training the NN models, the neural network models, which is actually the collection of neurons. And these weights actually serve as an efficient hyperparameter to make our prediction accuracy as high as possible, right? So if it is not correct, then what we'll be actually doing, we'll be calculating how much error is there, and we'll be applying some gradient descent mechanism to identify the global minimum error. What is the global minimum error I can get, that I will identify, and I'll be setting my training processes again and again. I'll be doing my training again and again. So this is a problem what we have actually taken, right? Like this. Yes. So for this, we have input 1 and input 2 with neuron values as 0.05 and 0.10 respectively. It is actually contributing to the hidden layer. There is only one hidden layer, say H1 and H2 is there, two neurons in this one particular layer, and this layer is also aided by a bias, and an input is also aided by an bias. We know why bias is used. Bias is used to provide some additional impact on my input so that I'll be getting an appropriate output what I can have, right? That is an additional layer which can also work on the intercept end in my plotting. Then I'll get the appropriate output, that is 0.01 for O1 and 0.99 for O2. So there is a binomial output over here. Right now, let us first see the forward pass, that is from input to output, how it is going to propagate. Now, can anyone say how to calculate H1 from these input layers? How to calculate H1? Anyone? Yes.
I1 W1
Yes.
plus I2 double
Very good. Okay, can you say with the numbers here?
0.05 into 0.15 plus 0.10 into 0.20.
Bias?
0.35 into 0.30.
No, no, what? No, no, no. This 0.30 is for this line. This bias line will not have any weight. It is just a plus. Usually, we will not give a weight for bias. Mx plus C
Addi-
only.
additional plus.
Yes, additional plus all. Right. So that is how I calculate H1. Similarly, how to calculate H2? I'll be taking 0.25 into 0.05 plus 0.30 into 0.10 plus the bias 0.35. In this way, I can calculate H2. And if I directly proceed with the H1 and H2 values into the calculation of O1 O2, it will be becoming like a normal machine learning algorithm. But what I have to use, I can use some activation over here. I'll use a logistic activation here, which takes 1 divided by 1 plus e power minus x, a logistic classifier over here, which will actually make my H1 values to get reduced to some other values. So it will be getting like 0.5932 when I apply over here. This H1, I call it as net H1, and actual output of H1 is calculated by using the logistic activation function. And using the H1 and H2 values, I'll be calculating the W1 and W2 values. That is, sorry, O1 and O2 values. How to calculate O1 is nothing but 0.40 into the H1 value plus 0.45 into the H2 value. Similar plus the bias 0.65. O2 can be calculated as point this 0.50 into H1 plus 0.55 into H2 plus 0.65 the bias. And I will again apply the activation for O1 and O2 and see whether the final output of O1 and O2 is equal to 0.01 and 0.099 or not. If it is not, then it means that I have some error and I need to get rid of that error. The actual output what I get for out O1 is nothing but 0.7605, but what I expect is 0.01. It is more higher error. And similarly, for out O2, I'll get some value as 0.7816, but actually I record 0.99. Some closer error is there. So what I can actually do, I can take the sum of squared errors. Here I have two output variables, so I divide the values by 2. Why? Because half of the error from this and half of the error from this will be totally forming the total sum of squares error. So I take target O1 minus out O1. That is that what is the value I actually require, that is 0.01 minus what I actually obtained from the model. So I take the sum of square errors. I divide it by 2. Why? Because there are two outputs. So it is actually mean sum of squares error. So if there are two, I divide it by 2. Both the things are divided by 2. So the mean sum of squares error I calculate as 0.3033, right? So this is what we have seen in the previous class for the forward propagation, that is forward pass of the neural network model. So any doubt is there up to this? If I give any model like this and ask you to calculate, like if I will be giving some diagram like this, and if I ask you to calculate H1, it is very much easy for you to calculate that H1 within 1 minute or 1.5 minutes, right? So don't forget that calculating H1 doesn't matter that you just substitute the values and get. You need to apply the logistic activation or something. So once activation is done, then only the output will be obtained, right? So then only your answer will be correct, right? So if we are given some options may have the value without being applied the activation function. So be careful, okay? Once the activation is done, only the actual H1 can be obtained. So this is output of H1, right? Net H1 is not the value. I need out H1, right? That's what with respect to NN model. Now we will see the back propagation. So what back propagation is? So this forward propagation, starting from the input to the output, is not giving me the expected results as 0.01 or 0.9. So what I have to do, I need to go back and update these hyperparameter weights. I need to update these 0.1525, 20305, everything I need to update. Once the weights are updated, it will give some better values. So how I need to update the weights? That will be the next question. What we can actually do, we have a back propagation network. So what I will first do, if you see the above diagram over here, if it is going from H1 to out1, I call it as W1 out, and W1 out over here is nothing but this particular thing, H1 to O1. That way I say as W1 out 1. If it is H2 to O1, I say it as W2 out 1. If I say from H1 to O2, I say it as W1 out 2. And if it is H2 to O2, I say it as W2 out 2. So W2 out 1 is nothing but 0.45. W1 out 1 is nothing but 0.40. W1 out 2 is nothing but 0.50. And W2 out 2 is nothing but 0.55. Now let us first understand how to update these four weights from the output. Now what will happen? I'm going to go from back to forward. That is back propagation. So these O1 and O2 will behave as inputs for me now. So let us see how it is going to be proceeded. Now, if I want to calculate W1 and by out1, what I have to use is I need to take a partial derivation over my the error, total error I have. I have the total error available here. This is my total error. So in this total error, I need to reduce the impact of W1 out 1. So what is the error obtained from this 0.40 alone? I need to reduce or increase this 0.40 so that the error from this 0.40 can be reduced. So because I'm going to update that 0.40 now. So what I will actually do, I take that. So here, how can I write this partial derivation? The dou E total by dou W1 out 1 is nothing but I can write it as dou E total divided by dou out O1 into dou out O1 divided by dou O1 into dou O1 divided by dou W1 out 1. If you see mathematically here, let me take the epic pen also. If you see mathematically here, there will be no difference when you actually cancel out these fractions. If you cancel out these fractions, then what will actually happen is now dou out 1 and dou out 1 will get cancelled, dou O1 and dou O1 will get cancelled, and we'll be again getting the dou E total divided by dou W1 out 1. So this is what you'll actually get also. This and this will get cancelled, and this will get cancelled, and again you'll be getting dou E total by dou W1 out 1. But there must be some reason for actually taking these particular versions, right? So why we are actually taking this? These the denominators and these additional multiplications are done in order to make the partial derivation to hold. Why? Because in dou e total, I don't have any term matching dou w1 out 1. I don't have any terms matching. So what I will actually do, first dou e total is actually directly related to dou out O1, and dou out O1 is directly related to dou O1. That is a net value before activation, and this dou O1 is actually having this dou W1 output. So if I want to do the partial derivation, then the numerator term should consist of this denominator term. Then only I can do the partial derivation. Otherwise, my partial derivation result will be null. So what I will actually take, I'll be taking the results like that. If you see the out O1 value, what is out O1 value is nothing but 1 divided by 1 plus e power minus O1, the logistic activation. I have the net to O1 value, right? That is what I have done here. Out to O1 is equal to 1 divided by 1 plus e power minus O1. O1 is nothing but the net value. We calculated net value, right? That is the O1 net to O1 value. And what is O1 then? O1 can be calculated as out to H1 into W1 out 1 plus out H2 into W2 out 1 plus B2. This and all we have already calculated. You see on the top, and now before you said, now you said, right, how to calculate that particular index values. If I want to calculate O1, O1 can be calculated as H1 into W1 out 1 plus H2 into W2 out 1 plus the bias, this B2 bias. That is what is given here. How to calculate O1 is out H1 into W1 out 1 plus out H2 into W2 out 1 plus B2. In this way we have to calculate this formula also we know. And what is E total value? E total also I know 1 by 2 into target O1 minus out O1 plus 1 by 2 into target O2 minus out O2. Everything we have already calculated and kept. All the formulas I actually have it. Now what I actually do? I take the first part in this partial derivation, dou E total divided by dou out O1. That is, the dou E total is nothing but this is E total value. This need to be partially differentiated with respect to out O1. I have to do that. So what I will actually do? So dou E total by dou out O1, if I partially differentiate over this. So if it is partial differentiation, I can directly consider what are the values that has out to O1. And if you see the second part, 1 by 2 into target O2 minus out O2 the whole square. Whether any out to O1 is present in this particular term, any out to O1 term is present in this particular term, 1 by 2 into target O2 minus out O2 the whole square. Any out to O1 is there?
No, sir.
No,
No.
sir.
If I, in differentiation, if I didn't have out to O1 term, what happens to this entire term?
0.
0. The entire term becomes 0, so I put it 0. Very good. Now here I have the out to O1 present. So what will happen is this 1 by 2 becomes a constant. So directly I write that 1 by 2, and x squared in a differentiation can be written as, if I want to do d by dx of, so since it is actually the partial derivation and only one term is there, I can directly write it as d by dx. D by dx of x squared, if I want to write, I can write it as 2 into x. Am I right or wrong? D by dx can be of x squared can be written as 2 into x, right? So like that I can write, so 2 into x power 1 2 minus 1. This is what I can actually do, 2 into x power 2 minus 1. So I'll get 2x as the value, and this x already has some 1 by 2. I have 2 into 1 by 2 into this entire term, target O1 minus out to O1 can be considered as x squared. So it can be written as 2 into 1 by 2 into target O1 minus out to O1, and this 2 and this 2 will now get cancelled, right? My out O1 is actually present in negative index, so I need to multiply it with minus 1. X is actually negative here, so I make it minus 1. I don't do any differentiation with respect to target O1. Why? Because it is partial differentiation with respect to out O1 only, right? So I get the total value as 2 to get cancelled. I'll be getting the result as minus of target O1 minus out O1, right? Now what will happen? I'll take the target O1 value. Target O1 value is 0.01. That is given in the question model itself. If you go and see, you'll be getting that. What is the target O1 value? Target O1 value is 0.01, and what is the actual, and what is the O1 out O1 value we actually obtained is 0.7605, and I subtract it and multiply by minus, I'll be getting 0.7505. So this is what the first part in the equation, dou E total by dou out over. I got that. Second part is dou out over by dou over. So I have actually written this Word document like part 1, part 2. Why? Because so that when you are reading it, you can understand it clearly. If you want, you can directly calculate everything. But for making you understand it clearly, I wrote like first part of one, second part of one, like that, so that the equation can be clearly understood. Second part is going to be dou out over by dou over. If you see here, dou out over is out over formula is 1 divided by 1 plus e power minus o1. So I want to differentiate with respect to o1, and the formula itself contains o1 as a single variable. So it is actually only one variable is there that is going to be derived, so there is no issue. Now we need to understand how to write this 1 divided by 1 plus e power minus x, right? So to make so that we can make the differentiation as easy as possible. 1 divided by 1 plus e power minus x can be written as e power x divided by 1 plus e power x. How is nothing but you multiply numerator and denominator by e power x. What will happen? Denominator also into e power x. So what will happen is e power x into 1 will become e power x. Next, this entire 1 plus e power minus x into e power x. E power x into 1 will become e power x. E power minus x into e power x will become e power minus x plus x, which will become e power 0, that is 1. So it will become e power x divided by 1 plus e power x. Right? Is it understandable how it we obtained this? Multiplying e power x on both sides, we can get e power x divided by 1 plus e power x. So when we are doing the first problem, you may think that we need to understand these things, but when you do the same problem again and again, the same logistic activation, then these formulas we can directly go on. You need not do this and all. You can directly go on to the final formula. Don't want these derivations and all, right? Then what I will actually do, I'll be taking dou o1 of f of x. F of x is now going to be e power x divided by 1 plus e power x. Now I need to do the derivation. How can I do? My derivation is actually present like this: x divided by 1 plus x. Like that, it is actually there. X divided by 1 plus x formula. So what I can actually do, I need to take the denominator also here into consideration. So what I can actually do, so I will take e power x into 1 plus e power x. That is the denominator term I take the entire denominator, that is 1 plus e power x. And if I want to take e power x as derivation, e power x on top, it will go as 1 plus e power x the whole power minus 1. Like that it will become. That is a Bernoulli's distribution. 1 plus e power x minus 1. Like that it will be going. So if I derivate this, it will become minus 1 minus of 1 plus e power x into e power x. So if I reduce that, I'll get minus of e power x into e power x divided by 1 plus e power x the whole square. This is actually the Bernoulli's distribution for calculating x divided by 1 plus x, and it is in binomial coefficient. So I'll be getting this value, and when I go down, I'll be getting this. If I substitute e power x into this, and if I reduce those things, e power x into e power x minus e power x into e power x will get cancelled on both sides. So I'll be getting e power x divided by 1 plus e power x the whole square. This is what I'll get. This e power x by 1 plus e power x the whole square can be written as f of x minus 1 by f of x, 1 minus f of x. How is f of x is nothing but e power x divided by 1 plus e power x. This is what f of x is, 1 plus e power x. And 1 minus f of x is nothing but 1 minus again e power x divided by 1 plus e power x. This is 1 minus f of x. So if I take LCM over this, then what I'll get is, I'll be getting like e power x. This 2 I can multiply directly, so I don't write the denominator, I take the denominator as a whole. In e power x into 1 plus e power x into 1, it will be taking as LCM, so I will get 1 plus e power x minus e power x. Minus this e power x is there, that e power x I can take 1 minus e power x whole divided by 1 plus e power x, 1 plus e power x is there, so I can take the whole square thing. 1 plus e power x the whole square. And what I can actually do, I can actually remove these x, e power x and e power x. And so what I, this is actually in the summation multiplication way. So I'll be getting as e power x divided by 1 plus e power x the whole square. That's what is written here. So we say that this 1 by e power x divided by 1 plus e power x the whole square can be written as f of x into 1 minus f of x. So there is a reason for writing this as f of x into 1 minus f of x. Why? Because if I write like this, can if before going to that f of x substitution, can you understand how we obtained this f of x into 1 minus f of x? Yes, can you understand how we got this f of x into 1 minus f of x?
Yes, sir.
Yes. So what I can actually do, this is f of x, that is 1 divided by 1 plus e power minus x. If we go up and see, we have clearly stated what is that f of x. F of x is nothing but 1 divided by 1 plus e power minus o1, and I already have that value 1 divided by 1 plus e power minus o1 value as out o1. If you go up and see, we have already calculated out o1 as 0.7605. So this is actually the f of x value. So what I need to do, 0.7605 into 1 minus f of x, that is 1 minus 0.7605. I'll be doing that. So I come here, this can be written as 0.7605, that is f of x, into 1 minus 0.7605. That is what I get it as 0.1821. Right? Is it clear? The second part of equation 1. Is it clear? Right now, going to the final third part, this will be easy part. That is the final dou O1 value. Now we see what we have taken as O1. O1 is nothing but out H1 into W1 out O1 plus out H2 into W2 out 2 plus B2. The corresponding weights into the values. We want to differentiate it with respect to W1 out O1. So the W1 out 1 term is present only in this particular way. And here from this there is no W1 out O1. So what happens to this particular terms?
0.
Very good. It will be fully become 0. And what will happen over here if I differentiate with respect to W1 out to O1? If I differentiate out H1 into W1 out 1, what will happen? Or if I differentiate d by dx of 2x, what will be the answer?
2.
Very good. Excellent. It will be 2. And if out H1 is going to be the constant and you are going to differentiate with respect to W1 out O1, what will be the answer for the differentiated value? Out H1 will be the value. So we go into that result. You itself said the answer. So we go there. Out H1 will be the thing. So if I differentiate, what will happen is, if I differentiate this particular term with respect to W1 out to O1, out H1 will be retained. And there is no out W1 out 1 here, so answer is 0, and B2 also doesn't have any W1 out to O1, so it also becomes 0, right? So this is actually that term. Finally, what I can do, I can just substitute out H1 value. So I go there and see what is out H1 here. Out H1 value is nothing but 0.5932. This is what out H1 value is. I just substitute the value over here. So since this is the first problem we see, we are actually doing these derivation and finally substituting out H1. But when you go for solving the next problem, if I ask you to find the third term, you directly take the out H1 and then put the answer. You need not do these much derivations, partial things and so on. You directly know out H1 will be the value for this. If I want to derivate with respect to W2 out to O1, if I want to find, I'm now finding W1 out to O1, I'm finding now. So the answer is out H1. If I was finding W2 out to O1, the answer will be out H2. That is what the difference going to be there. You'll be seeing when I do this problem for finding the next weight, and if you see the size in which I have solved the problem, you'll be seeing how much small the problem is actually. Right now, finally take the total. So the E total of W1 out to O1 is, we see the formula that this is what, that is dou E total by dou out to O1. That first part. Second part dou out to O1 by dou O1. And third part dou O1 divided by dou W1 out to O1. We have the three parts here, and we can do that three parts multiplied over here. That is 0.7505 into 0.1821 into 0.5932, and we get the answer as 0.08107. So this is what the error reduction that can be obtained by the W1 out over. So using this particular reduction thing, we can actually update the W1 out over weight as W1 out over minus the learning rate eta into dou E total by dou W1 out over. I have set here the learning rate as 0.5 so that the model learns 50% each time. That's what my assumption. Usually eta will be between 0 to 1. Keeping eta as 1 is not a good habit. We have to keep it and we cannot keep it 0 also. Then it means that model is not learning anything. The good values will be maybe between 0.3 to 0.6. So I keep it as 0.5, assuming that the model will learn 50% each time. And my current W1 out O1 value is 0.40. Now I'm going to update this value. So what value is going to come now is 0.40 minus the eta 0.5 into 0.08107, this particular value. I take it and my new value for W1 out O1 is 0.3595. So in the back propagation, I have calculated the first weight as W1 out O1. So that value is recognized as 0.3595. It has reduced. The weight has been reduced from 0.4 to 0.3595. Now with this, I'll be explaining you this W1 out O1. With this W1 out O1 also, will explain you how to calculate W2 out O1. So it is actually wrongly mentioned here. It is W2 out O1. See how easily I'm doing that. So if I want to do with W1 out O1, the E total should be differentiated by W1 out O1. If it is actually with respect to W2 out 1, then what I have to do, differentiate it with W2 out 1, not W1 out. So what are the changes will happen? This entire term will be same only. This entire term also will be same because I'm going to use only out 1. For out 1, everything is same as O1 only. Only difference is the final term, that is W2 out 1. So these terms I already have as 7505 1821 already calculated before only. Only updation what I have to do is O1 with respect to out O2. Now I will not show what will be in the bottom. I'll just show up like previously one of you said the current answer. So I'll be going up and ask you if this is the O1 value and we need to find W2 out 1. Then what will be the value? When I want W1 out 1, you said that out H1 is the answer. I want W2 out 1. I want to differentiate this O1 with respect to W2 out 1. What will be the answer?
Out H2.
Very good. Out H2 will be the answer. That is my only update. Out H2 will be the answer and it is right. So out H2, I already have that out H2 value at 0.5968. I already have that out H2 value. That is the only updation I'm going to do for the update for the next weight calculation. So see the how W2 out can be calculated. Same 0.7505, same 1821 into instead of 0.5932, I'm actually keeping out H2 as 0.5968 and I get the new value for the E total with respect to W2 out over. Okay. Now using this, what we can actually do? Now we can calculate the updated weight for W2 out 1. What will be the updated weight? If you see here, updated weight, we need to subtract the value. So what will be the weight for the thing? I'll be taking this. So this is W2 out 1. The updated plus represents the updated weight value. And what is the W2 out 1 value currently now? W2 out 1. So this is actually 0.45 it is. 0.45 is the current value. So we need to update this. So 0.45 can be reduced as, I keep the same learning rate here, 0.45 minus 0.5 into 0.18156, and what will be the value? I'll calculate. Have this 0.45 minus 0.5 in 0.5 into 0.08156 minus 0.45. It is 0. I have taken 0.45 here. Actual answer is without negative. So the answer is 0.40922. 0.40922. So this is what the actual answer is. Updated which, right? So there is 0.45, it is now reduced to 0.40. Is it clear how we are calculating W2 out to O1? Is it clear?
Yes, sir.
Yes, sir.
Yes. Now we have to calculate the out 2 values. If out 2 is present here, if I want to calculate the E total with respect to out 2, what are the differences will come here? What will become the here? Now we will be doing that. Yes, you have to say me so that I'll be getting the
Chain
same.
rule differentiation, sir.
Yes, yes, not as a maybe like chain rule differentiation. Ultimately, what I'm doing is, if a particular formula is there, I need to differentiate that formula with respect to the content present in that formula. Because if I want to differentiate E total with respect to W2 out to O1, W2 out to O1 is not present in E total itself. So only we are going for the chain rule like what you say. So now
Okay.
finding the next value. So this E total, I'm going to find it with respect to out O2. W1, this is what I'm going to find. So W1 out 2 I'm going to find. If I want to go with respect to out 2, then I can keep it everything as with respect to out 2. And this is W1 out 2. Right? Now we don't have the values already present here. Let us go with the first part, or let us write the formulas we have for these. So we know E total, out, O2, everything. And the formulas are already available. The numerator formulas are accurate. We'll take all the formulas and put it here. So what is E total? E total formula we have here. We take that and put here first. This is E total. This is E total. And what is out O2? Out O2 is nothing but 1 plus e power minus O2. This is called out O2. And finally, O2. I need O2 value. And here it is, the O2 value. Now let us do the derivations for part 1. Now, you say me, what will the values? Dou E total by dou out O2. In this particular 1 by 2 into target O1 minus out O1 the whole square. Any out O2 value is present or not?
No, sir.
Very good. So I put 0 plus, this is actually the term. So what I can actually do, I can bring 2 into is continue 2 into can write 2 into 1 by 2 into target. Oh, can write 1 by 2 into target O2 minus out O2. That whole square is actually being brought here and into minus 1 because out O2 is in minus. So I put minus 1 here. Right? Is it clear? So this 2 and this 2 will get cancelled. So the answer should be target O2 minus out O2. So what is target O2? O2 target should be actually given in the question. 0.99 is actually the target. And what is actually out O2 is 0.7816. So I take both. 7816. So what is the value? 0.99 minus 0.7816. I get 0.2084 as the final 0.2084. This is dou E total by dou. Next, the next second part, this part, dou out O2 by dou O2. But I can actually write here f of x. What is that formula? It can be written as what?
F of x into 1 minus f of x.
Very good. I can write it as f of x into 1 minus f of x. Now I can put on the where f of x is equal to, this is actually the formula for f of x. 1 divided by 1 plus e power. I consider this as f of x. There, I don't want to do the derivations again and again for each problem. I understood how to do, so I can directly do what I want. So what is out to O2? I'll see. Out to O2 is nothing but already I calculated and kept out to O2. Since the font size is big, you may think that it is problem is high. Problem is very small. Font size is actually kept as 16. Out to is 0.7816. So I can give it as equal 0.7816 into 1 minus 0.7816, which will be equal 1 minus 0.7816 into 0.7816. I'll get 0.1707. 0.1707 is the value. Final part, third one. So O2 by W1 out2. So this is also straightforward. You can say the answer directly also. I'll go and show you what is O2 formula. This is O2 formula. I need to differentiate with respect to W1 out to 2. So W1 out 2 is present in this term and it is not present in this term. So what will be the answer for W1 out 1?
Out
Sorry, out
H.
2. Out H1 alone. Yes, out H1 alone I'll get. So this is out H1 into plus 0 plus 0. So what is out H1 value? I'll take. Out H1 value is over here. H2 is this. 0.5932 is the H1 value. 0.5932. So I get the result. Now all the three parts are ready. Let us calculate this final answer, that is dou of E total hence will be equal to, this will be equal to multiply all. That is first one is 0.2084 1707, everything we are going to multiply. So 0.2084 into 0.1707 0.5932 will be equal to 0.2084 into 0.1707 into 0.5932, which will be equal to 0.2236. 0.02236. I get this result. So I'll take one more time, 0.2084 into 0.1707 into 0.5932, and I'll get it. Oh, sorry, I get it. 0.084 into 0.707 to 0.5932. 0.2110 only. 0.2110. Yes, I get this as result. So W1 out to minus eta. I have to give eta. Eta into, I'll be taking this entire term. So what will be the value over here? What is the previous W1 out to value? W1 to out to I want to go, that is 0.50. So this is the term. I'll go here 0.50 minus, I'll take the eta also as 0.50, 0.5 into, and my eta total value is 0.0211. So what will be my answer? Minus 0.50. I get 0.48945. 0.48945 is the updated weight, right? I reduce it by 0.2 something, right? Is it clear how we are doing it? Updations. The back propagation in neural network is clear.
Yes, sir.
Yes. Final weight, one more weight is there. If anyone is going to fully say, I'll be happy. We have one more weight available. We have calculated, see, W1 out to calculate. Next is W2 out to. We need to calculate that. Can anyone say that fully? We need W2 out to. What will be the difference in the formula? This part is okay. O2.
Yes, sir.
This part
Yes, sir.
and this part finally.
W2O2.
Very good. W2 out to. So I get, and these are the terms already available. So only thing what I need to concentrate here is with respect to O2, I need to differentiate. Formulas and all same. So now this is actually already available. This is already available. I can actually take the answers alone of these things. So this formula is, this answer is 0.2084. Exactly the same thing I'm going to use. So I directly write it as 0.2084. We can say that we have equal to 0.2084. We already have this. Next, this also the same. We already have this 0.1707, 0.1707, and we have the third thing we have to calculate. So we have out O is present here. So let us calculate the third term alone. Out O2 should be differentiated with respect to W2 out2. We have to differentiate with respect to W2 out2. So what will be the values? This particular term, what will happen to this?
0.
Very good. This particular term entirely becomes 0 plus,
Out H2.
very good, plus W2, sorry, out H2 will be there plus 0. So what will be the total answer? I take the out H2 value. The forward pass itself, I have calculated and kept everything. So I go to the forward pass and take out H2 value. That is 0.5968. 0.5968 is the answer. So I take this. Now we have to calculate the total particular result, which will be equal to 0.2084 into 0.1707 into 0.5968, and which will be equal to 0.2084 into 0.1707 into 0.5968, which will be equal to 0.0212. 0.0212. So now update the weights. Updated weight, that is W2 out2 we are going to take. W2 out2 updated weight can be represented as plus, and we return as, how can we write this? W2 out2 minus eta into tau E total weight dou W2 out. If I take this error's value, so this error will be learned. So this error will be learned and will be subtracted from this weight. So let us find what is the result. The updated weight. It's W2 out2. What is W2 out2 value in the given question is? W2 out2 is 0.55. So let us decrease this 0.55 from the error. 0.55 minus the eta value I have kept as 0.5 into, and what is the value of we have 0.0212. 0.0212, which will be equal to 0.5 into 0.0212 into 0.55, sorry, 0.5 into 0.0212 minus 0.55. I'll be getting 0.5314, 0.5394. So this is the value. I have updated the weight. So what are the updated weights from output layer to hidden layer? So what are the updated weights from output layer to hidden layer? We can enumerate everything. So what are the weights we have updated is nothing but, put it all here. I think 4 times we need to put this. 4 weights are updated now, and this is W1 out 1, and this is W2 out 1, and this is W1 out 1, and this is updated as 0.40 is updated as 0.3595, and next is obtained as 0.4092. What is the first one? 0.359, 0.3595, and this is 0.4092, and over this here is this is the value 48945, 48945, and keep it 4 digits, and finally W2O2 out 2 is 0.539, 0.539. This is what the weights we have calculated and given during the back propagation. Weights are updated. And if you see, if you ask that whether the back propagation is done, no, it is not still done. Why? Because now we have calculated these 4 weights, and from the backward we have moved to the hidden layer now. From hidden layer, I have to move to the input layer now. From the input layer, I have 4 weights. These 4 weights also should be updated. Once these 4 are updated, then what I can actually do, I can again substitute the 0.05, 0.10 with these weights and then proceed towards here. And at that time, I will see what is the total error. Based on that time, I go forward and backward. Then these forward backward passes will happen in several epochs. This going from forward and coming backward is considered as one epoch, and this epochs, number of epochs will increase several times to make that E total, the total that is a mean square error value, to decrease as much as possible. Sometimes over, if you see, the weight value will tend to increase at a particular moment, means that you'll be getting some error, which is will error being increased. That error increase may be considered as a local error, local minimum error, but at the time you need to be very careful and use some gradient descent mechanisms to understand that no, if it is still increasing also, sometimes it will decrease even more further. So that until we cannot do it in pen and paper, we have to see it in practical, right? Is it clear, the neural network model and how to do this? Clear? Is it clear?
Yes, sir.
So I'll post this in Google Classroom also. Yes. So with this, we have done our unit 4 also. Now we can also we can be done with the professional examinations portion, that is covering unit 3 and unit 4. We have a class by tomorrow as well as on Saturday. In some good time, we will be revising the unit 3 and unit 4 also. You see in the Google Classroom, all the materials are here for you to study. Everything is posted there, and you concentrate on the problems also. The problems, I mean, these neural networks, nearest neighbors, and when you see something like decision trees, you have to see how the ranges will be going on. What is the range for entropy? What is the range for Guinea? For example, entropy may range from 0 to 1. Guinea will be ranging from 0 to 0.5. So those things also you keep in mind. And when you go with the third unit, you hope you remember the partial correlation, the multiple correlation, those formulas. Everything fully shared in our Google Classroom. You go and revise. I will also revise you in maybe in a Saturday's class. Right? I'll be revising you unit 3 completely and unit 4 completely. So you'll be doing well for your sessional examination. Well, okay. Yes. If you have any doubts, you can also ping me and you can be replying. Right? Yes. Shall we proceed?
Yes, sir.
Yes. So this is what I the next thing. And if it is from unit 5, I go directly into the practical is two reasons. One is this practical session. Second is we have already seen clustering in predictive analytics itself. Predictive analysis we have seen k-means clustering, agglomerative hierarchical agglomerative clustering, and hierarchical divisive clustering. We have already seen the implementation of these clustering in R Studio. We have seen it in R. So now the thing is, we are going to see the same in some k-means, and to make it more innovative, I have used the again the ESPN Quick Info data set to do this. So what will be the plan now for this is we will first discuss how we are actually doing it and how the clustering is being happen, and next you can try. And this particular the collabs will consist of all the clustering algorithms and this particular data set and how each clustering algorithm is giving us some different results. That is what we are going to see here. Let us understand how to code. The code is actually simple, and we can understand how the clustering should be done and how the gap analysis can be done. Everything we can say do here, and let us go into that. And before that, we can see the data set. This data set we have already used for the classification, the nearest neighbors and all, like whether the batsman is aggressive or not. For those things, we have used this particular data set, right? Yes. So for this, we have average, we have economy very ready, and we have done classification based on strike rate. Like if it is greater than 65, he is not done. He is a defensive bowler, and if it is less than 65, it is an aggressive bowler. So now what I'm going to use is I'm going to take the average and economy alone, and I'm going to do the clustering based on the average and economy alone. So let us see how the bowlers can be clustered, right? So I import the NumPy. I require the unique and where these particular functions I require from NumPy, and this is actually not required since I referred an internet. They used already defined a randomly generated data set. So I didn't use that. So I have generated my own data set from ESPN Quick Info already. So I don't require this particular thing. And from sklearn, we can use the k-means, and from matplotlib, I'm importing the pyplot, right? So let us see how we are going to do. I read the CSV file, that is ESPN Quick Info Bold Stats. That is what I have here. Next, I fix my features to be clustered are average and the economy alone. Next, I convert them into a NumPy array. Why? Because we know that k-means clustering or any clustering algorithms is intended to run only on numerical data items, and that numerical data items also need to be in a array type, not in a data frame type. So I convert it into a NumPy array. Next, I create a k-means model with clusters is equal to 5. There is a reason for fixing the 5 value. I will say you because in the elbow method, I got that 5 is the best value for clustering. So I fix this 5. I'll explain that also. Next, I fit the model with the features and I calculate the prediction values, right? So let us find, and for this, from this on, we are actually doing the plotting things where I take the cluster and take the unique of this. Why I take unique is I have totally around some 1750 values, and there are actually 5 clusters, each clusters ranging from 0, 1, 2, like this, 3, 4, right? So what will actually happen is yes, so we have actually want to reduce it and make it unique. Unique. So once I make it unique, when what will happen is I'll take those 5 values around and I plot. Whenever I get because if I directly plot, what will happen is these values will be scattered, like something yellow here, something orange here, like that. It will be scattered. Since I clubbed everything together, so first I'll be getting all the orange. Next I'll be getting all red, blue. They like that. It'll be getting. So this is what the clusters we obtained for the particular k-means clustering, right? We have already seen k-means clustering. It has some features where initially it requires the cluster to be fixed, and once the clusters is fixed, also it is having some thing like it need to specify the initial cluster centers also. So these are actually some disadvantage. Initial cluster center should be prepared, number of clusters should be said, everything, right? And when the data size is large, it can actually take advantage of all the different perspectives, and we can also use the gap analysis method to find the number of clusters. So this is with respect to the k-means clustering. Similarly, we can also do for the hierarchical clustering. And before going to hierarchical clustering, we can actually take this elbow method. This elbow method, what I actually taken is I have run from 1 to 10 clusters, 11 minus 1, 10. So 1 to 10 different clusters, and I have taken for k means, and I fitted for x. I found that if you see the within cluster sum of square WCSS, that means that within cluster sum of squares. I'll write here within cluster sum of squares. This is actually the thing. Within cluster sum of squares value should be as low as possible. So initially it is very high, and when I was actually reducing it, it was actually decreasing. And if you see that at the cluster 5, it is said to be converged. In 4 also almost it is converged, but in 4 to 5 I find some decrease over here. So a steep decrease. So I fix it as 5. The cluster strength as 5, and I run it. So I get 5 different clusters values. For that is 5 different categories of the bowlers in this 1750 data. Similarly, I can also find it for agglomerative clustering, where instead of the importing k-means from the sklearn cluster, I import the agglomerative cluster. That is the only difference. Remaining all everything is same except agglomerative clustering of n clusters is equal to 5. I know that 5 is the best clustering value for this particular data. By using elbow method, I found that for k-means. For agglomerative also, I fix bias d as pi itself, and I get these different types of clusters. You see further, I'll be having the DB scan clustering, which is new for us. So instead of directly seeing the DB scan clustering, that is density based scanning method for clustering, we'll be seeing it first mathematically, then we'll be going into the practical sessions of. Now I want you guys to actually, yes, once you have opened the Colab, put S in the chat box. Once you have opened the Colab, put S in the chat box. Proceed towards the Colab. I'll be showing the screen first for you. To proceed with the k-means clustering and the agglomerative clustering. For DB scan, we'll be seeing it later once we see the mathematical modeling of the DB scan cluster.